The universe is vast, with billions of galaxies, trillions of stars, and uncountable planets. It's impossible not to wonder, are we alone? Today, I want you to come with me while we dive into one of humanity's greatest mysteries, the search for extraterrestrial life. So why are scientists so convinced that life might exist beyond Earth? Well, for starters, life on Earth has shown extraordinary resilience, thriving in extreme environments such as boiling hot springs, frozen tundras, and deep-sea hydrothermal vents. This gives us hope that life could adapt to conditions on other planets. And then there's the sheer numbers game. The Milky Way alone has over 100 billion stars, and many of them host planets. In 1995, the first exoplanet was discovered, named 51 Pegasi b, a hot Jupiter. And now we know of over 5,000. Some of these planets are in the habitable zone, the region around a star where conditions might allow liquid water to exist. Adding to our hope of finding extraterrestrial life was the discovery of extremophiles, like tardigrades and bacteria surviving in radioactive or boiling environments. Their resilience provides a blueprint for the kind of life that could survive on other worlds. So how do we search for extraterrestrial life? Well, it starts with powerful tools. The James Webb Space Telescope and its predecessors like the Hubble Space Telescope have revolutionized how we observe distant planets. By analyzing the light passing through exoplanet atmospheres, scientists can detect chemicals like oxygen, methane, or even water vapor, which are all potential indicators of life. Another approach to finding extraterrestrial life is listening for it. SETI, the Search for Extraterrestrial Intelligence, scans the skies for unusual radio waves. Well, the idea, if advanced civilizations do exist, they might be sending out messages. More recently, and closer to home, missions like the Europa Clipper and Mars rovers are directly exploring worlds within our solar system for signs of microbial life. Upcoming missions like the Perseverance rover's samples return, or potential explorations of Europa's geysers, will bring us even closer to answering the question, are we alone? Despite all the possibilities, we still haven't found the definitive proof of extraterrestrial life. This is what's known as the Fermi Paradox, first proposed by Enrico Fermi in 1950. If intelligent life is so common, why haven't we encountered it? Well, there are several possible answers to that question. One theory suggests that we actually are alone. Another suggests that intelligent civilizations self-destruct before achieving interstellar travel. And some scientists believe advanced aliens might deliberately avoid us, considering humanity too primitive to contact. History does offer us some intriguing clues. In 1977, astronomer Jerry Emmon was shocked to find that overnight, Ohio State University's Big Ear radio telescope had picked up a strikingly intense and narrow radio transmission from space. This which lasted at least 72 seconds. On the printed data report, Emmon famously circled this series of letters and numbers that represented the signal in bright red ink, and he scrawled a now famous word in the margin. While unexplained, it remains one of the most tantalizing mysteries in SETI's history. Could such signals be evidence of distant civilizations, or are they merely cosmic coincidences? The Drake equation is one of the most famous tools for estimating the likelihood of extraterrestrial civilizations. Developed by Dr. Frank Drake in 1961, it's a mathematical formula that considers factors like the number of stars formed each year, the fraction with planetary systems, and the likelihood of life developing on them. While the equation doesn't give us a definitive answer, it's a way to frame the discussion and identify what we need to learn. For example, recent discoveries of thousands of exoplanets have helped define some of the variables, but for others, like the fraction of planets where intelligent life arises, remain largely speculative. Depending on the values you plug in, the results range from "we're probably alone" to "the galaxy could be teeming with life." The Drake equation remains a powerful reminder of both the possibilities and the uncertainties in our search. This brings us to the concept of the Great Filter, a theoretical barrier that prevents life from advancing to a spacefaring stage. The Great Filter could already be behind us, such as the rare emergence of complex life, or it could lie ahead of us, in the form of technological self-destruction, or insurmountable challenges in interstellar travel. If the Great Filter does lie ahead of us, it might explain why we haven't detected any other civilizations. they just didn't make it. This idea challenges us to be mindful of our own survival as a species. The Great Filter poses some profound questions. Are we rare? Just lucky survivors of immense challenges? Or are we heading toward an inevitable hurdle that no species can surpass? Now, imagine the universe as a vast, dark forest. Every civilization is a hunter, lurking silently, trying not to reveal its position. This analogy forms the basis of the dark forest theory proposed by science fiction author Liu Cixin in the Three-Body Problem series. The idea is simple but chilling. Intelligent civilizations might avoid broadcasting their presence out of fear. In this cosmic forest, revealing your position could invite danger from more advanced civilizations. Survival, therefore, depends on your silence. This suggests that any civilization capable of receiving our signals could also possess the technology to annihilate us. This is a stark contrast to the optimistic views of interstellar communication, and challenges our assumptions about the intentions of extraterrestrial beings. Given our decades of broadcasting television, radio, and radar signals into space, some wonder, have we already made ourselves vulnerable? The dark forest theory urges caution and raises ethical dilemmas about active messaging to the stars. The universe is not only stranger than we imagine, it is stranger than we can imagine. J.B.S. Haldane, 1927. Whether or not the dark forest theory holds true, it reminds us of the stakes of cosmic communication could be unimaginably high. Are we the hunters, or have we already become the prey? In 1974, humanity made a bold move. Scientists at the Arecibo Observatory in Puerto Rico sent a powerful radio message into space aimed at the distant star cluster M13. Known as the Arecibo Message, it was our first deliberate attempt to communicate with an extraterrestrial intelligence. The message contained information about our solar system, humanity, DNA, and even basic elements of math and science. All encoded in binary, it was a digital postcard designed to say, "Here we are." While it would take tens of thousands of years for the message to reach its destination, the Arecibo Message symbolizes humanity's hope to connect with the cosmos. It also serves as a reminder of how small and interconnected we are. Whether or not it ever receives a reply, the message reflects our innate curiosity and desire to understand our place in the universe. Led by scientists like Frank Drake and Carl Sagan, the project inspired future efforts in interstellar communication. Yet, it also sparked debates about whether announcing our presence to unknown civilizations is wise. The Arecibo Message is an act of optimism and bravery, a testament to humanity's willingness to reach out into the unknown. As we send more signals into space, it prompts us to consider, what message should we send next? And who might be listening? But have we found any hints of life? Well, maybe, but nothing conclusive. On Mars, we've detected methane spikes, which on Earth are often produced by microbes. Similarly, Jupiter's moon Europa and Saturn's moon Enceladus have subsurface oceans that could potentially harbor life. In 2020, scientists announced the discovery of phosphine gas in Venus's atmosphere, a chemical that could be a byproduct of life. While still heavily debated, it does show how close we might be to uncovering some answers. The hints keep piling up, but we need more direct evidence before we can say we've found extraterrestrial life. If we discover extraterrestrial life, or they discover us first, what should we do? The ethics of contacting extraterrestrial civilizations is a hotly debated topic among scientists and philosophers. Potential benefits and the dangers are immense. Historically, we've taken some bold steps, such as the Voyager Golden Records, which carry sounds and images of Earth into interstellar space. These were designed as a message for any intelligent life that might find them. But is this a wise strategy? Some argue that broadcasting our presence might expose us to threats from more advanced civilizations. Others believe that the search for extraterrestrial life inherently carries a risk, but also offers profound opportunities. The chance to exchange knowledge, culture, and even warnings about universal dangers could benefit humanity in ways that we can't even imagine. But can we trust that other civilizations would share this perspective? The divide in opinion highlights a fundamental uncertainty. Are other civilizations likely to be friendly, neutral, or hostile? The answer might depend on their evolutionary and cultural context, which we can only speculate about at this point. Ethical questions also extend to whether we should actively send signals into space, a practice called active SETI. Some advocate caution, suggesting that we should first focus on detecting life before attempting communication. Others argue that it's too late for caution now. After all, Earth's radio signals have been leaking into space for decades. Ultimately, the ethics of contact underscore the responsibility that comes with such a monumental decision. It's not just a question of science, but of humanity's collective values, hopes, and fears. The search for extraterrestrial life is one of the greatest quests of our time. From scanning distant planets for clues to debating the risks of interstellar communication, the possibilities are as vast as the universe itself. But what does it mean for us?
The cosmos is also within us. We're made of star stuff. We are a way for the cosmos to know itself.
It's a humbling reminder that we are connected to the universe in ways we're only beginning to understand. Whether or not we ever find intelligent life out there, the search itself deepens our understanding of who we are and where we come from. So, what do you think? Are we on the brink of discovery, or is the truth about life other than our own still light years away? Let us know in the comments. And if you enjoyed this journey, don't forget to like, subscribe, and share. Join me as we continue exploring the wonders of the cosmos. Thanks for watching, and I'll see you next time.